Hello, ladies and gentlemen, and thank you so much for joining this brain talk. And we will discuss in this lecture is the central core of the brain. We'll start by Bismillahir Rahman Ar-Rahim. And all these images is coming from the legend Albert Roughton. We starting firstly is this is here is the ventral colostrum spread out in the uncinate fascicles to reach the amygdala here. Here is an axial action section. Sorry, this we have like anterior limb of the internal capsule is located between the head of the nucleus and the lentiform nucleus. What is the lentiform nucleus? We have discussed this before. Is composed of two structures. The first one is the putamen. The second one is the globus pallidus. Here is the posterior limb of the anterior capsule and is located between the lentiform nucleus and the thalamus. Here is the genu, is the adjunction of the anterior limb and the posterior limb of the internal capsule. We have here very nice pictures of the genu of the internal capsule, and this view is coming from the superior lateral. Here is the anterior limb, here is the posterior limb, and here's the ventricular system, and here's the foramen of Monro, and here is the corpus callosum, and here's the lateral ventricle. This is, in this superior lateral view, we can see that the genu is located just only behind the anterior commissure. At the same coronal level of this level, we can see the foramen of Monro and the genu, and also the posterior short gyri or gyrus, as we see in this picture. All of these in the same line. After removal of the anterior limb of the internal capsule, we expose something called the head of caudate nucleus. This is the internal capsule here. Here is the ventral colostrum, which spread into, as we said before, into the uncinate fascicles to reach the amygdala. The uncinate fascicles is a frontotemporal long association fibers pathway, and this is the sulcus limitus of the insula. The uncinate fasciculus, has a dorsolateral part which goes to the orbitofrontal area. And it has also a ventral medial part which goes to the septal area here and extends to the frontal or to the temporal pool here. So clinically, some DTI studies has in patient with schizophrenia have found morphometric changes in the uncinate fasciculus. At the same time, disturbance of these uncinate fasciculus during the anterior medial temporal lobectomy has some associated with psychosocial clinical improvement, because the uncinate fasciculus can no longer convey the pathological information from the temporal lobe to the orbital frontal cortex, which involved in the decision making. Here is the orbital frontal area. Here is the uncinate fasciculus. Here is the temporal pole. We are now looking from the above. Here is the dorsolateral part of the uncinate fasciculus, which project to the lateral orbitofrontal area. And here is the ventral medial aspect of the uncinate fascicles, which project to the septal area and also the medial orbitofrontal area. Here is a very amazing picture of the caudate nucleus from the head and body and the tail. It's like a C-shaped structure. This is also, as you can see, head and body and tail of the caudate nucleus. It's also, the head of the caudate nucleus, or all the structure of this caudate nucleus is from the lateral part of the lateral ventricle. Here is the lateral ventricle, and this is the caudate nucleus. Lateral ventricle is in the medial side, and the lateral, the caudate nucleus is in the lateral part of this lateral ventricle. So we are kind of looking from above now. We see the caudate nucleus here as a lateral part of this ventricle system. And here is the corpus callosum, and here's the cingulum here. And these fibers coming from the corpus callosum. The caudate nucleus is surrounding the lateral part of the thalamus. This is thalamus here, and this is the caudate nucleus wrapping around the lateral part of the thalamus. There is something called stereo terminalis, is travel between the thalamus and the caudate nucleus. After removing the thalamus, which was here, we can see the position of the caudate nucleus in relation to the inferior limiting. Here is this called the anterior limiting sulcus. Here is the superior, and here is the posterior. And this is the caudate nucleus. As we can see, the head of the caudate nucleus is positioned in areas called the anterior insert point, which is the meeting point between the superior and the anterior. So during the operation, we must be careful, or we must locate the anterior insular area, because that we cannot or can be prevent damaging to the caudate nucleus. And we also has called posterior posterior insular point, which is in the area of body of caudate nucleus. And this is a meeting point between the superior limiting sulcus and also sulci, and also the posterior limiting sulcus of the insula. So violating this point can damage the body of the caudate nucleus. Below the posterior insular point, there is called the tail of the caudate nucleus, and it travels behind the inferior limiting sulcus. Here is the inferior limiting sulcus, and this is the tail of the caudate nucleus. Here is the inferior limiting sulcus, and we see in this area is the tail of caudate nucleus, and going to the amygdala. Here is the amygdala. And we see now from above, we look to the rest of the basal ganglia, basal ganglia structure. We are looking from above, as we said before. There is called the accumbens, nucleus accumbens, which is located under the head of the nucleus. The head of the nucleus has been removed here. We can see in this area is the head, and under it is the accumbens nucleus. There is also a subthalamus nucleus, which is located in the ventral lateral to the red nucleus. Here is the red nucleus, and this is the ventral lateral of the subthalamus nucleus. And here is a posterior view of the encephalic area. We can see the subthalamic nucleus is positioned ventral lateral to the red nucleus. And here is the internal capsule. So the subthalamic nucleus is between the internal capsule and between also the red nucleus. Here is the red nucleus, and here is the internal capsule. Here is a lateral view. We can see in this structure, this substantia nigra is positioned, in the ventral space or the ventral, location of the subthalamic nucleus. Here is the subthalamic, is substantia nigra, and there is a red nucleus in the medial side of this structure. Basal ganglia is just only is like a center core of the brain, and it has a connection with cerebral cortex and also the brainstem. As we see, there is more fibers coming to or going to the cortex, and at the same time there is coming from the brain, coming from the cortex to the brainstem and to the spinal cord. The projection fibers, as we see here, is and here is a relationship to the lateral ventricle. Basically the frontal projection fibers is called the corona radiata. Here is the corona radiata. It's mixed of fibers coming from the internal capsule of and external capsule in the basal ganglia. So the corona radiata fibers is around just only medial to the superior longitudinal fasciculus, was called SL1 and 2, and also there is occipital projection fibers, which called the sagittal stratum. The sagittal stratum is medial to the inferior fronto-occipital fasciculus, or it's also medial to the inferior longitudinal fasciculus, and this also medial to the occipital extension of the anterior commissure. As you can see here, this is the anterior commissure, and this is extension to the occipital, and this is the frontal or inferior frontal occipital fasciculus. Sagittal stratum is medial to the occipital extension of the anterior commissure. Here is the inferior longitudinal fasciculus, which is lateral to the sagittal stratum, and here is the anterior commissure, and its extension to occipital area. So in medical, removal of the inferior frontal occipital fasciculus and occipital extension to the anterior commissure expose the sagittal stratum. The sagittal stratum is composed of occipitopontine fibers and also occipitothalamic fibers. We have occipitopontine and occipitothalamic, which the occipitothalamic fibers is called the optic radiation. Here we can see this is the optic pontine, optic also thalamic radiation fibers. The optic thalamic fibers is called the optic radiation. As we can see here, this is the optic radiation is coming from the lateral geniculate here in this area. This is the lateral geniculate body in this area, and coming from here is the optic radiation. And the optic radiation travels in the roof of the lateral ventricle of the temporal horn. We see here is the temporal horn, and also lateral to the atrium to reach the calcarean sulcus. So 1/3 of the atrium is free from the optic radiation. So doing operation in this area cannot damage the optic radiation. Calcarean sulcus in the occipital area. And the optical radiation, can separated from the temporal horn and atrium of the lateral ventricle by the tapetum, which coming from the corpus callosum of the spleen or splenium of the corpus callosum. Here is an axial view from above. We can see this the atrium here and occipital horn of the lateral ventricle. The atrium and the occipital horn of the lateral ventricle are covered laterally by the sagittal striatum and also the tapetal fibers in this area. Whereas medially there is a forceps major in this area. Here's the occipital sagittal striatum here. This is sagittal striatum, and this is the tapetal fibers laterally, and medially we have the forceps major of the lateral ventricle. Here is the atrium of the brain, optic radiation in this area. So in this medial wall of the atrium, there is a bulb or something like, extension to the atrium. It's called the bulb of the corpus callosum, which overlying, the fibers of the forceps major. Calcar avase is overlying the deep end of calcarean sulcus in the inner wall of the atrium. The anterior bundle of the optic radiation is called a Meyer's lobe, and Meyer lobes extend at the tip of the temporal horn. So we must be careful when doing operation in the temporal horn or doing some, some operation in going to the basal ganglia or removing the some middle temporal gyrus. Sometimes that's can violate Meyer's lobe. And beneath the amygdala, the optic or Meyer's lobe, there is amygdala, which forms the anterior wall of the temporal horn. The hippocampus is located in the floor of the temporal horn. And after removal of the thalamus, we can expose the third ventricle. This is also here is called stria terminalis, is coming from the septal area. The septal area is located, around the anterior commissure in the midline. Here's the anterior commissure, and it's coming here from behind or around the anterior commissure. Here is the anterior commissure in this area, stria terminalis, septal area. And the stria terminalis is wraps around the thalamus and also going to the amygdala. The stria medullaris, also this another concept, is coming around the thalami and extends from the septal area to the habenula in this area, from the septal area to the habenula. And by this, last picture here, we finished our lecture about the ventricle of the brain. Thank you so much for listening, and we will continue our last lecture about temporal and frontal and the limbic system anatomy. Thank you so much again. See you.